Good morning to everyone. This is Karthik, working as an assistant professor in the Department of Electronics and Communication Engineering. Today we will start a discussion on the partial shading detection in a solar PV panel. Let me go for the next slide. This is the flow of presentation. First one is introduction. Next one IV characteristics of PV cell, IV characteristics curve of the PV cell, solar PV array parameters, partial shading in a PV array, and what is the purpose of using this blocking diodes and bypass diodes. So last one is finally the question is. Let me introduce about the PV partial shading conditions. So before we are going for the partial shading conditions, so where it is appear in the partial shading conditions. Generally our partial shading condition is appear only in the solar photovoltaic panels. So renewable energy electricity resources plays an important position in the power technology. So there are so many resources like wind, solar, geothermal, ocean thermal and biomass could be used for the so many years. So among these renewable energy sources, our solar photovoltaic energy is increasingly more well liked these days because of its profitable nature. And PV module is the essential gradient in a system which transfers sun energy into electrical power. So let me go for the next slide. So this is nothing but the IV characteristics of a PV cell. So in our circuit diagram we are having only single diode model we are using. So there are lot of types of diodes are there. Single diode model, 2 diode model, 3 diode model are there. But among the 3 diodes model, single diode model is the very efficient one. So that is why we are using for single diode model. In generally common used electrical circuit model to characterize the electrical action of a PV cell in a single diode model. So you can see from the circuit diagram we are having the diode is parallel with your resistance, that is shunt resistance, and we are connecting a series resistance. So in this finally we are measuring the output voltage from the PV panel. Next slide. So this is nothing but the equation of the IV characteristics of a PV cell. So generally the equation represents the IV characteristics of a PV model are represented in the following equations. So as before we are seeing the circuit diagram. So according to the Kirchhoff current law we can apply the equations. So phase current that is equal to diode current plus shunt current plus the normal current. So what is the expression for the diode current? So the current in the diode is nothing but the I naught, so which is nothing but the reverse saturation current, which is exponential of V plus RSI divided by thermal voltage A minus 1. This is a second equation representation. Next. The equation represents the current in the resistance which is given by shunt resistance, that is shunt current. ISH is equal to V plus RS into I divided by RSH. And from the equation, that is a previous equation, we can get the expression as the total PV current, that is I is equal to phase current minus ID minus ISH. And you can substitute the above equations, that is 2 and 3 equations in equation number 4. Our characteristic equation will becomes like, this is nothing but big equation. I is equal to phase current minus, we are substituting the second equation and we are substituting the third equation. So in that we are representing that the VT is nothing but the junction thermal voltage. So thermal voltage can be defined will be following expression as NS, that is series number of cells KT divided by charge of the electron. Next. So this is nothing but the IV characteristic curve of a PV cell. So in this diagram you are going to see what are all the parameters, that is open circuit voltage and short circuit current. So see from the graph. So first one is PV graph and IV graph, both are combinedly we are making in that single graph. So in that we are attaining a maximum power point that is we can say it as a MPP. So in that P is equal to voltage into current, so maximum current and IV current. So this is the normal representation of a solar PV cell. So this is nothing but the under uniform irradiance conditions we are experiencing these type of IV curve. Next slide. So this is nothing but the solar PV array parameters. So what are all the PV array parameters we are having? First one is open circuit voltage, next one short circuit current. What is the meaning of open circuit voltage? It is the maximum voltage that the PV array, that is photovoltaic array, provides when the terminals are not connected to any load. So this value is much higher than the maximum voltage, that is peak voltage, which relates to the operation of a PV array fixed by the load. So this value depends on the number of PV panels connected in series connection. So how much PV panels we are connecting, that is the we are represented as a open circuit voltage. And second one, short circuit current. So the maximum current provided by the PV array when the output connectors are shorted together. This value is much higher than the maximum current, which relates to the normal operating circuit current. So next one, another parameter is maximum power point, that is this is very important for the solar PV array, that is maximum power point curve. So it relates to the points where the power supplied by the PV array that is connected to the load, we are connecting a batteries or inverters, it has its maximum value. That is we can normally we know that voltage power is nothing but the product of voltage into current. So in this parameter we are experiencing maximum peak power, that is maximum power point. So we can represent it as the product of maximum current and maximum voltage. So the maximum power point of the PV array is measured in watts or peak watts. And next one, the very important parameter is fill factor. So fill factor is nothing but it is calculated by dividing the actual rated maximum power by the theoretical maximum power. So this can be done how many number of PV panels we are connecting in a connections. So the numerator denotes that maximum power. So maximum power is nothing but under uniform irradiance condition. Normally our PV panel working as a standard test condition as 1000 watts per meter square and 25 degrees Celsius, that is the maximum power. So divided by your open circuit voltage into short circuit current. Next one. So this is our main topic, partial shading in a PV array. So when it is happened, so we are having so many number of PV panels in our day-to-day life. We are having in our buildings or any other things we are connected so many panels. So in that our partial shading will occur when some part of a module is under shade. So it will lead to the formation of a local hotspot and the cell will not pump the electrons. So that as soon as the shade is occurred abdina, as the shade is occurred, it will the voltage will not be appear. So a bypass diode is connected in parallel to the damage itself will solve this problem. So during the partial shading condition, there will be a formation of local peak so that the current will decreases in steps, thus delivering a lower value than the rated value. Such a condition can occur during uniform change in irradiance condition. So this is the image of the partial shading condition in a PV array. So the first image we can look at as our trees, some other objectives are shaded in a PV array. So and next one is our clouds. So normally we know that during daytime and during night time. Daytime completely it will be charged, but night time it will be completely discharged. So during the night time we can utilize this PV panel in terms of power production. So this is nothing but the two images for the partial shading in a PV array. Next one. So we are connecting two type of diodes. One is bypass diodes, another one is blocking diodes. So what is the purpose of these diodes? We can see our next slide. We are connected to 4 panels. So in the 4 panels, we are connecting the PV that is bypass diode in a parallel connection, and we are connecting a blocking diodes in a series connection. So this will eliminate our partial shading in a PV array. So what is the purpose of using bypass diodes? A bypass diode is used in a case if one of the PV panels of a multi-panel string is faulty. That is, if some other obstacles appeared means if it is a faulty condition, it will bypass the faulty panel by providing a current to an alternative path to flow. So thereby it maintains the continuity of a power production. So what is the function of this bypass diode means is to eliminate the hotspot phenomena which can damage the PV cell, and even if it causes a fire if the light hitting the source of the PV cells in a module that is not in a uniform condition. So under uniform irradiance condition, normally our PV panel will experience 1000 watts per meter square, but under abnormal conditions means it will be the temperature will be very much equal, but radiance of the power will be somewhat lesser, that is 800, 600, 400, it may be some different shading level will happen. So that we can eliminate this radiance in terms of bypass diodes. Next one, blocking diodes. So what is the purpose of using blocking diode means during the daytime the solar panel at a high potential will produces electricity and charges the battery at the lower potential, and during nighttime conditions when the panel is not producing any electricity, so the battery is at a higher potential, so we can utilize that during the night time. So there is a possibility of the current flowing from the battery to the solar panel, thereby discharging the battery overnight. A blocking diode allows the flow of current from a solar panel to the battery, but it prevents or block the flow in opposite direction. This is the main purpose of using blocking diode. So what are all the next slide we can discuss? What are all the partial shading mitigation techniques are there? So as we already discussed about that, partial shading will causes trees due to happening of trees, buildings, clouds, dust accumulation. And what are all the effects we are experiencing during the partial shading condition? Hotspot, multiple peaks and losses. And how to mitigate the partial shading conditions by means of maximum power point tracking, that is nothing but the MPPT tracking. Second one is bypass diodes. Third one is multi-level inverter, and fourth one is array reconfiguration techniques. So among all the four mitigation techniques, recently our array reconfiguration technique is used widely in our day-to-day in our research papers, and some journals we are experiencing this type of mitigation techniques. So in our next session we will discuss about the these type of mitigation techniques and how it can be eliminate the partial shading in a PV array. Any questions? We can post it in the forms, that is Google form. So thank you.